Into this house we're born, into this world we're thrown, like a dog without a bone, and actor out alone, riders on the storm. There's a killer on the road.
We're here at Cerro Overo Maar in the Northern Chilean Andes, and this is a rare example of more mafic magmatism. This is why we have come here. You can see dark rocks in the foreground. This is some of the eruptive products of the maar, and there's a large block field just in front of us. And this is what we're driving through, but there's also some light-colored materials in the maar walls, in the inner walls, and that is some of the older country rock that is exposed there. And much of this older country rock that was located in the center of the maar has now been blown out and is part of the deposits outside the maar. Mars are very short-lived features usually. They erupt on a month time scale or maybe several months, but they're not long time eruptive features, i.e. no years or things like that. The eruption here took place about 100,000 years ago, and it is strikingly similar to La Boruna, which we have also recorded the other day, only that La Boruna is a cinder cone, and Maar volcanoes form when magma hits groundwater, and this is probably what happened here. The mafic magma might have been very similar to La Boruna, but it might have come in contact with groundwater, and this led to the explosive fragmentation as a function of converting magma to steam. This will increase the volume of the steam or the water when it's converted to steam by factor 1000, and the volume increase will really create an overpressure that will make these rocks fly out. It's the cause for the explosion rather than gas overpressure, as is often the case for more felsic rocks. When they erupt explosively, it's because the gas has been too much in the system, while here it's actually extra volatiles in form of groundwater, for example.
Well, actually, I have a question for you, but have you seen this before? I mean, places that you can find cinder cones and different places, maar deposits with the same features or characteristics. Please let me know if...
Yes, absolutely. Yeah. There's classic work by people like Schminke, who was my PhD supervisor, and he worked in the Eifel volcanic region. And he was one of the first to point out that whenever you have volcanism there on ridges, it happens to be cinder cones, and when you have it in valleys, it happens to be maars, because there is where the water are. And this has now been also shown for the Canary Islands, for example, that there's a frequent distribution of maars in the lower ground and cinder cones of the same magma type in the higher ground. So the main difference between these different volcanic features is not the type of magma, it is the environment in which the magma was intruded.
Okay, I see. And well, what about the geological setting, I mean the context? Because here is subduction zones and, well, as you know, the crust is really thick. So
yes, this is the intriguing feature here. This is why I find this so spectacular. The crust is usually a sort of filter. Magmas get stuck, and when they are in the crust, they differentiate. That means they cool and crystallize and change the liquid composition of the remaining magma. Or they interact with the country rock, they assimilate materials, and that will also change the composition. This material here seems surprisingly low in terms of crustal interaction or differentiation, i.e. fractionation, and this makes it particularly interesting. So here's the truck of our colleagues. They're sampling already in the crater wall. And this feature of a low evolution, of a primitive degree of evolution, is what makes this site so spectacular.
I see. So, well, I think that we have a big question here. How supposed to be this mafic volcanic stream, and why so similar to La Boruna, which is low?
Well, I mean, this is something we discussed the other day, and of course I really don't know, but it may be that the that the big Altiplano Puna magma body that is partly under us is a main reason for that. That the mafic magmas, they're trying to come up and they might not be able to penetrate through that magma body, and they seem to sometimes at least exploit the sides of this. So they're coming up like a fringe around, or like a corona around this major magma body, and therefore they are partly avoiding interaction with this felsic magma, and this could be a reason for their limited degree of interaction. But this is something we will have to work out with further research.
Yeah,
this is just a speculation at this point, or let's call it more than that. It's a working hypothesis for us.
Yeah, absolutely. Well, thanks, Val, for your explanation.
Oh, thanks Osvaldo for your input and your questions, and for bringing us here in particular.
I'm glad that you're here.
So am I. Yeah. Thank you very much, and I hope you enjoyed our little trip around the Maar, and we'll say goodbye with a nice view on the volcanoes in the background, but we haven't quite worked out their names yet. Bye bye, all the best.
All the best.